Hello, everyone, and welcome to the first session of our UTC annual conference in the wireless track. Today's session is 700 megahertz A block buyers and potential buyers and user group roundtable. My name is Klaus Bender. I'm VP of Engineering for UTC. I'd like to thank our sponsors for this event, Access Spectrum and Select Spectrum. I have some housekeeping notes before we begin the panel discussion. Participants are all on mute for this presentation. We have 23 people and climbing now, so we don't want to open the mics for potential audio feedback. So if you have questions, I direct you to the question box in your GoToWebinar interface. You can enter questions there, and those questions will be forwarded to the panelists, and the panelists will address them at the end of the presentation. The presentations, both the slides and the recordings, will be available after the conference. The presentations will be available in the UTC community network, the networks community, and you should be able to log in and download presentation slides from there. The recording of this session itself will be available on demand for registered attendees of the conference the whole way through the beginning of November. So you would just navigate to the event that's already occurred, click a button that says join webinar, and then the presentation will start again, and you can watch it on demand for the remaining next 3 months. Professional development hours forms will be posted in networks. I believe that what we're going to do is professional development hour certificates for the entire conference. So what we're going to end up doing is sending you all a list of the sessions that were provided in this conference, and you check the ones that you attended or listened to on demand after the fact. There will be an email sent as well after the meeting is over for evaluations. Please provide feedback, any feedback you have on this session or other sessions on the conference. Obviously, this is our first attempt at a virtual conference, so we'd like as much feedback as possible. If you haven't already done so, you can keep track of what's going on with the UTC app that's available for Android and iPhone platforms from their respective video stores. That conference app is free. And we'd also remind you to go visit the exhibitor gallery in the interface or the web page that you log into for the site. The exhibitor gallery has valuable information from our exhibitors, and you can set up conversations with them and download information from them. So with that, I'm going to introduce Chris Lalou from Great River Energy as our initial moderator for the session. So I'm going to put myself on mute, and Chris, it's all yours.
Good morning or afternoon, everyone, depending upon where you're calling in from. Welcome to the 700 megahertz users and prospective users UTC Roundtable session. As Klaus mentioned, I'm going to be today's moderator, and I'm Chris Lalou from Great River Energy. For the first 20 minutes, we're going to hear from several utilities that have already purchased the 700 megahertz A-band. During their 2 to 3 minute case study updates, you'll be allowed to ask questions by typing them into the chat feature of GoToWebinar. At the end of the utility case studies, the utility representatives will address questions which may include questions from potential users. After the utility case studies and related questions, I'll be throwing out topics for an open discussion, again to utility members alone, to both participate and ask additional questions. Should you not have the opportunity to ask your individual question, or if there remain other questions, your host and I will make sure we connect you with the correct person after the session to provide answers. And as Klaus mentioned, this is going to be recorded for all participants, and he'll make sure that we all get that link. So first up, let's hear from Kathy Shaft from Great River Energy.
Hello, everyone. This is Kathy Shaft. I'm a principal telecom engineer with Great River Energy. I've been working for GRE for, I think today is actually my 16-year anniversary, so it's been a while. Next slide, please. So this slide is just to give a quick overview of GRE service territory. You can see we cover about 2/3 of the state of Minnesota, and this is showing our 28 member cooperatives throughout the state and just where they're located. Next slide, please. So we recently completed an upgrade to our system at the end of last year. Prior to that, we had been operating a VIO network, which we started installing back in 2006. VIO went out of business in around 2011, and so we were self-supporting the network since that time, and the equipment was getting we were running out of spare equipment, getting outdated, things were failing, so we had to upgrade. So we chose MIMOMAX as our provider, our vendor for the new network. The map that I'm showing here shows the location of our base stations. So we have 60 towers that cover our territory. Most of them are 3-sector sites, and we cover about 470 substations. I'm not showing those on the map, it just gets to be too crowded. We're using the network for our SCADA traffic and metering. Our 28 members, the majority of them are also using the network to backhaul their traffic, and we also use it for remote access for our field staff. We're using 50 kilohertz channels with this new network. Our old system was using 330 kilohertz channels, and with that limited amount of channels, we experienced quite a bit of ducting issues on the old network, and now that we've moved to smaller channels, it's made a huge difference in mitigating that problem. As I mentioned actually I didn't. I said we had our VIO system, but we have been leasing the spectrum up until this point, and we are planning to purchase the spectrum in Q4 of this year. One of the challenges that we ran into when upgrading our network was that since we were already using the 700 band and all of it, we were using the entire channel for the VIO system, we had to figure out a way to cut over to the new system and mitigate the amount of downtime for our SCADA traffic. So what we did is we installed Cisco 829 routers at all 470 of our substations, and that router has a built-in SIM card slot, and so we used that, activated Verizon as a backup path so that anytime there was a disruption of service on the 700 network, that router would just automatically fail over to the cellular network. So that enabled us to change out antennas throughout the system at both the base stations and the remotes. And while those antenna changes were happening, everything would just fail over seamlessly to the cellular side, and there was hardly any impact to our system operations. They'd see a little blip, and then communications would be back up. That's also what we used when we were cutting over. We cut over by channel. So we had those 3 channels. So we started with the first channel. That was December of 18, where we cut over 1/3 of our network to the new MIMOMAX radios. It took us about 8 days to go all across the state and install all of those radios at both the bases and the remotes, get them up and running. During that time, those radios were failed over to the cellular network. Then once we got the MIMOMAX radios up, then we had actually 2 systems running. We had 2/3 of the network running on the old system, and then 1/3 of it running on the MIMOMAX network. And then at the end of 19 is when we finished cutting over everything else. And so now we're all fully cut over, been running since the end of 2019 on this new system, and things have been going well. So that is my update.
Hello, my name is Stephen Osbath, First Energy. I'm a Director of Network Engineering and Operations. Next slide. So First Energy, we operate over 6 states. We have customers in Ohio, Pennsylvania, New Jersey, West Virginia, Maryland, and New York. Actually a couple of small counties in New York, about 6 million customers. And as of very recently, we are now a fully regulated company, transmission and distribution, and we do have a couple of regulated generation plants. We purchased our 700 megahertz spectrum back in 2017 and 2018. We really just split that up between 2 years due to budgetary reasons. And we purchased of the 159 counties that we operate in and have customers, we purchased in 118 of those counties. I'll follow up in a second about why that was and how we optimized our purchase. The key drivers, probably the biggest thing was the legacy circuit replacements. Like all utilities around the country, First Energy is dealing with the obsolescence of analog TDM circuits, primarily used for SCADA. We had over 1,500 circuits that we needed to replace as of 2014. We're about 2/3 done with that now, and 700 megahertz is a big part of our strategy to get those circuits replaced and onto our private network. The other thing that we're seeing is a significant growth in substation and SCADA line devices. So 700 megahertz provides us a platform for that. And we were previously, for the field area networks, using a lot of MAS radio 900 megahertz unlicensed. And we were starting to see growing interference on these bands, and I'm going to elaborate that in a second as well. So that was another key driver for us. And 700 megahertz, as you all know, it's in the Goldilocks zone. It's got a very good cost, frequency, and bandwidth characteristics. So propagation through obstacles, range is very, very good. And we didn't, for the applications that we're going to use it, 3 meg would have been, not that we can always use more bandwidth, but in terms of a balance between cost and our use cases, the 1 meg up and 1 meg down really satisfied our needs. We did look at the 2.3 and 2.5 gigahertz solutions that were being proposed. They were, because of the shorter range of those frequencies, the build out of towers would have been cost prohibitive when you look across all of the rural territory that we have in all of those states. We are using GE orbits. We have them with dual SIMs and dual cards, so we are able to implement both 700 megahertz and cellular. Very often when we don't have a base station, we'll implement on cellular, and we don't necessarily need to replace the radio. We just need to put up the 700 megahertz antenna once we do get the base station in place. And like GRE, we're also using 50 kilohertz channels. Next slide. So how did we optimize the purchase? This was very important because we do have all types of customers in our service territories. We have very urban areas like Cleveland and Erie and other places in New Jersey, but we also have suburban, remote, and rural. So what we did is we did some analysis, looked at the customer per population ratio, and what we found was the areas, there were many counties that we just didn't have the customer density in that county to warrant purchasing 700 megahertz. So in and around New York City, in and around Philadelphia, Pittsburgh, we were able to drop those counties off and really optimize how much spectrum we actually needed within the service territory. So of the 159 counties, we dropped 41, purchased 118, and we were still able to serve about 92–93% of our customers as a result of that, but yet achieved almost a 44% savings in spectrum costs. Next slide. So a little bit about the unlicensed spectrum that we were using previously. If you go down to Home Depot or Lowe's, you all know that you can walk down the aisle and probably find 200 products that use these same unlicensed frequencies. Well, at First Energy, we were definitely seeing the impact of that on our unlicensed radios. We were seeing radios dropping out frequently. If you go to the next slide, we did some spectral analysis, and we were able to see that it didn't matter whether we were in an urban area. You can go to the next, there you go. It didn't matter whether we were in an urban area, a suburban area, or even residential or rural. We were still seeing interference well above the acceptable noise floor. And what we found very interesting, we have an AMI system that operates on a mesh network for 2.2 million customers in Pennsylvania. And whenever that system operated, it was actually causing interference on our 900 megahertz unlicensed radios. So we were interfering with ourselves from another part of our network. Next slide. So where do we stand? A little bit about our strategy. 700, I have 700/900 because in those counties that I talked about earlier, where we don't have 700 megahertz purchased, we would seek out 900 megahertz licensed spectrum in order to satisfy that need. So 700 is primarily for substation and line SCADA communications. It really forms the backbone of that system going forward. We also have cellular for remote areas. We use it as a stopgap solution. So we don't have a base station. It takes a lot more time to do the propagation studies and everything that's required to get 700 megahertz to a location. So very often we'll put an orbit out there as a cellular device and then come back later and do 700 when we get the base station in place. And then, as I mentioned, we operate over cellular. We have a number of cellular CGRs for AMI in the state of Pennsylvania. Where we have very dense, high-density applications like distribution automation and volt bar control, we operate a mesh network. We use a Tropos system, and we can even overlay the 700 megahertz on that if we need to get to specific locations that aren't served by that mesh. And then where we have high bandwidth applications, we have a pretty large investment in fiber and microwave throughout the company and continue to expand that. So mainly in the transmission substations where we have cameras, PMUs, digital fault recorders, and that sort of thing that requires that high bandwidth. So the current status, we do have 115 master sites online and 283 remote sites. Now, while that ratio seems very low of remote sites to masters, we are targeting 30 remotes per master site or per sector, or for omnis, 30 remotes per omni. The reason why you see that ratio so low is because we spent the first couple of years really focusing on meeting the safe harbor criteria, which was due middle of 2019. And as a result, we had to hit all of the license areas, and we are in 10 different MEAs. So that really forced us to do things not as efficiently as we would have liked had we just had the ability to roll from one end of the service territory to another. So we'll see those remote sites go up very, very quickly. We have about 3,100 SCADA cellular sites. All of those are future candidates for 700 megahertz. So as we get our base stations further deployed, we'll be focusing on migrating as much of that SCADA as we possibly can over to the 700 megahertz network. As I mentioned, we have also have our cellular AMI in Pennsylvania, and in mesh networks in Ohio especially, we have a grid mod initiative going on with the state of Ohio, where we will be rapidly deploying mesh networks. So that is my presentation. Thank you.
Good afternoon, everybody. My name is Kimberly Traylor. I am the Director of Network and Telecom for JEA. I've been at JEA for about 18 years. For those of you who aren't familiar with us, we are located in North Florida. We cover approximately 1,200 square miles in Duval, Nassau, and St. Johns counties. And our service territory also, we have the benefit of about 700 miles of JEA owned fiber and 40 communication towers. So in 2019, JEA began working with several pilot technologies to address an issue that has been plaguing us and many other utilities for some time. Over the years, we've built multiple ad hoc wired and wireless networks that were application-centric and performed very specific functions. Today, we have a couple dozen networks that are mostly incompatible. So as part of our considerations for the next generation for digital grid, we began to look at LTE-based technologies, primarily because they are a standards-based solution with the ability to provide the reliability, the latency, and the scalability that we were looking for in an IoT platform. As we look ahead, we will develop a strategic and holistic long-term approach for our service territory. So this would include all of our sensors. We are looking at our SCADA and DA applications. In probably March, April of last year, we partnered with Select Spectrum and Paluli to actually run a pilot on the 700 megahertz solution that they have for NB-IoT. We leveraged our existing communication towers and have installed Paluli's base stations, radio heads, panel antennas, and endpoint sensors in the field. In our initial testing, we've yielded about a 25-mile radius that we were able to cover for this solution, which was pretty exciting. So we've done 3 different use cases. The first one, we did a baseline test with a temperature sensor, and that was basically to test the radio link performance. We tested temperature and humidity with a data frequency of about every 15 minutes. The second use case was generator monitoring, and this is really important to us, especially living here in Florida with the hurricanes, that we wanted to be able to monitor our generators for things like oil pressure, speed, and coolant temperature. And we were able to capture this data on the on status of the generator at a frequency of about every 5 minutes. All of this data is currently being brought back to our PI system. The last use case that we are currently working on is our water pressure transducer. And the current communication that we use for that is the sensor through the PLC and into a SCADA gateway. But using the NB-IoT infrastructure, we are able to put a small sensor out in the field in remote locations and bring that back to one of our communications towers and fiber backhaul it to our data center. And the reliability of our pilot to date has been at least 4 nines. The sensors that we are using can be deployed separate from your standard PLC SCADA infrastructure. And the solutions that we were looking to solve as part of our use cases were leak detection, boiled water alerts, allowing our folks to know about preventative maintenance. And then another interesting concept came up about using this same technology for JEA's consumptive use permits. So this would allow us to monitor the water draw and collect that data as well. And that's where we are on our initial pilot and use cases. And I think John had a couple of questions I see in the chat. So I'd like to go ahead and address those. John's first question was the adoption and approval of the banded to 3GPP NB-IoT standard as key. Are utilities as an organized group ready to move forward with this standardization? And what would it take with tier 1 manufacturers like Nokia and Ericsson to back the standard on the radio access? Or is it even a possibility for them being based on a US business case from the utility industry? So I know, John, Paluli's working with the device vendors and the chip manufacturers for standardization, and they're going to be leading that effort in the coming months. I think key to note is that the channelization and technical specifications have already been completed and they've been implemented in Jacksonville and other places. So Kathiz, did you have any other comments? He may be muted. John, we'll follow up. And then question 2 is how can utilities come together to create product demand that would justify the business model for equipment manufacturers of RAN and N devices, especially when funding is tied to rate cases where implementation is often years down the road? So I do know that Paluli's business model is network as a service, so that it will not require a large capital outlay upfront. And then in regards to creating a product demand, I believe that an organization like UTC that can pull together multiple utilities would help drive the equipment manufacturers to adopt this standard. So hopefully that kind of answers your couple of questions. John, if you have anything else, I'll be happy to address it at the end. Thank you.
All right, Jared, it's all yours.
Hi, I'm Jared Fagan. I work for SRP. I've been here for, just under a year. We have about 1 million meters and serving the Phoenix metro area. We have also managed water here, about 13,000 square miles of watershed, over 1,200 miles of canals. And so we built this field area network on the upper A block. We built a 2-tier system, and it's to support with the wireless coverage here in the Phoenix metro area. And, wanted to look forward to things like more IoT as it relates to power and water, smart grids, anything like that. And it's, like everybody else, we're looking for reliable, robust, resilient, and secure system. So next slide. It's broken into 2 tiers. The first tier is a higher bandwidth, lower latency for those systems that need it. And then our second tier has a lower bandwidth and higher latency. Also on our tier 2, we provide roaming, something similar to roaming. If a truck parks in front of one of our radios, it will switch to a next best radio. Next slide. We have 47 of those tier 1 sites, and 2 of them are on our mountaintops here. We have 350 tier 2 sites currently deployed, and we're on our way up to around 1,200 supporting this Phoenix metro area. And we're doing metering controls, distribution integration right now are the main people that are using it. We're looking to include things like water, SCADA, et cetera, et cetera. Next slide. We're looking, turnkey wireless solution for all of our internal customers. We, like many others, use 900 megahertz unlicensed and LTE and things like that. We wanted the opportunities for advanced inverters, charger stations, make sure we had coverage for that. And then, as our customers change, we wanted to have flexibility around there, and eventually full monitoring of all of our resources. Next slide. Is that it? Oh, so just a couple of additional notes. We did start out with 15 kilohertz channels, and because of our relatively flat environment, we kind of overpropagated that, so we had to move down to 25 kilohertz channels on both tier 1 and just move tier 2 to 25 kilohertz as well, just to help control some of that self-interference that some of the other panelists have talked about. And it's been a good challenge for us to manage that as well. That was it.
All right. Well, thank you to the panelists for sharing your individual projects and case studies. At this point, we'd like to open things up to some discussion topics. The first topic, actually, before we do that, I'd like to ask the panelists if you'd open up your video and be ready to jump in here. So the first question we'd like to talk about is key elements of the business use case that supported a spectrum purchase. So areas similar to but not limited to financial considerations, availability and choice of equipment, bandwidth, price, and prospects of new technology. So does somebody want to jump in and start? And then if you have questions, if participants have questions, feel free to type them into the chat and we'll address them as they come in. This is the interactive part. Does anybody want any one of the panelists want to jump in and talk about how you conducted your business case? If you did, in particular, if you didn't cover that.
Chris, this is Kim Traylor with JEA. Right now, we're actually going through the process of developing our business case for our field area network. So at this time, we have not purchased spectrum. Actually, I found Stephen's last slide, which I captured, maybe as some key points that we wanted to take a look at, because we struggle with, some of the same things. Obviously, reducing our operating cost, making the most of capital investment. So we're going through that process probably within the next 3 to 6 months to develop our business case.
All right.
Yeah, for Synergy,
one of the things that we had to do was find a couple of big internal customers that had some big challenges that we could use this wider field area network to kind of justify what we were doing and when. So things like metering, really getting after a couple of big places to justify the initial purchase so that we can, make it available to wider customers.
All right. Stephen, you have something?
Yeah, just with the size of our service territory, we were really looking for more of an enterprise solution. And prior to that, if we weren't using unlicensed spectrum, which we all know that the pitfalls of that, which is another reason why I know everybody's worrying about that in the microwave level with 6 gigahertz potentially being opened up to lots of consumer devices. But where we wanted to get licensed spectrum, it was really hit or miss. We, on a county by county basis, we would really have to scratch and claw at what's available. And we just didn't want to keep doing that. We wanted to have one consistent platform across 6 states, and this was the best opportunity for us to do that at a reasonable price point, where we're not talking about a big wide band that would be cost prohibitive.
Okay. I think what we'll do is, if there's no other questions coming in, there's one question that did come in. I think we'll handle it in the next section, actually, related to interference. But the next topic is around adjacent geography band planning, basically being a good neighbor and channel planning for neighboring license owners in the 700 megahertz A block. One of the things that I should mention is that we have a best practices white paper that was prepared by Lockard and White that UTC has made available and will post in the UTC website. This is something that we had asked for, not just Jerry, but others had asked for when we first started looking at purchasing the spectrum, to figure out how we were going to make sure that we all played well. And there was a topic that came in, or a question that came in: has anyone experienced interference issues, and how were they resolved? And the short answer is yes. But that's a big discussion topic in and of itself. And so one of the things I think what I would like to do is propose that we raise that as the first topic of our next user group meeting. So right now, the group with UTC is trying to decide how frequently this group will meet, whether it's monthly or quarterly, or how often. So Klaus and others from UTC will be sending out some information about this group in particular. And so I'd actually like to propose that we have that as probably the topic of an entire session, because we could spend an hour or more just talking about that. The short answer is, like I said, yes, we have experienced interference with both Verizon and AT&T FirstNet, but both of them are working to help us resolve that. And so the hope of this user group, from GRE's perspective, is that we can band together collectively and figure out how we can get them to be good neighbors. Are there other questions related to geography band planning and things like that?
There's none here, Chris. But I had a message for Jared. Was it Jared that said that you segmented your traffic between low latency demand and high latency demand? How did you do that? Did you implement it on separate channels, or is it something within the equipment architecture that let you implement that?
So yes, we use separate channels as well as different radios. So what's driving the bandwidth is we have the radios we bought, for those familiar with MIMOMAX, the Tornado radios versus the Pixis radios, as well as on separate channels.
Okay, excellent, thank you. I still don't see any questions coming in, Chris.
Okay.
The one thing on the previous topic, the one thing I would just say is for the interference, we spent a lot of time dealing with our self-interference. So I know we talked about, we're talking about the issues we have possibly with AT&T and Verizon, but we spent a lot of time and shot ourselves in the foot for interfering with ourselves. That's why we had to go to the 25 megahertz channel. So it's something to think about.
Okay, so go ahead, Kathy.
I was going to say, we've experienced a lot of self-interference issues as well, and especially on our old network, only having those 3 channels. Under normal, I would say, atmospheric conditions, everything would run fine, but then when we would have the transition in, say, spring and summertime with temperature changes, we would see a lot of self-interference using just those 3 channels. So now moving to when we initially rolled out with MIMOMAX radios, we started with 10 channels and left the other 10 open so that we could kind of use them where we might have issues. We've started seeing a little bit of issues, and so now we're using about 16 channels to get things cleaned up. So we have 4 clean channels out there, so that if we do see any type of an issue with the site, we could move it to one of those clean channels and see, are we still seeing an issue? Because then we know, well, it's not us, it's somebody else that, you know, could be interfering. But so it's been nice to have those extra channels there to keep clean and try to figure things out.
All right, we do have some questions coming in now. So the first question is for Kathy. Can you please elaborate what the criteria is for switching from 700 megahertz A block to cellular backhaul? Is it based on aggregated data that triggers the switch?
So I know that it's somehow internal in the Cisco 829. I'm not a network engineer, so I don't know the rules that they wrote in order for this to happen. But once the router senses that the 700 network has been down, I believe it's set for 3 minutes where it's not seeing a connection there, then it just automatically fails over to the cellular network. Then once it's able to detect 700 is back online, it just automatically switches back. So that's my understanding of it. I don't know the internals and how it all works, but that's a high level.
There's a couple other things I would expand on, Kathy. Obviously, you know this a lot more than I do, but 700 megahertz is our primary preferred method of communication from a cost perspective. So basically, we already have the spectrum, so that's what we want to use. We use LTE as a backup if we need it. We've had some instances where members are using our network and they needed more throughput than we could provide for the 700 network. So we actually have them running primary on the LTE network and using 700 as the backup. But for GRE uses, we use 700 as our primary and just use LTE when we need it. Let's see. Next question is for Stephen. What's the exact 900 megahertz licensed spectrum you are using along with 700 megahertz license for substations?
Rod Kaufman, you want to take that one?
Sure, I can. Can you hear me?
Yes.
Yep.
Yes, we're using the narrow band 900 channels right above 928. In some cases, we're able to get 25 kilohertz channels. In other cases, only 12.5, depending on the congestion and availability of them. In many parts of our service territory, however, and as well as probably everywhere else, they're very hard to come by, and those that we have, we value dearly.
All right, thank you. Next question, I'm assuming this is for Jared. With the fan deployments, what is the backup connection if the 700 network is impaired?
Once we move to the 700 megahertz, we don't really have a backup on a per radio basis. Like I said, if a tier 2, we have a backup base station that the end user station could go to. But outside of that, we're not running LTE as a backup or anything like that. We do have, in places where the fan doesn't exist, we do offer some, we have some users using LTE or 900 megahertz unlicensed, things like that.
All right. Next one, this is probably for everybody. How has your organization approached capitalizing the purchase of the spectrum versus O&M? I can cover this for GRE's perspective. So we are planning to use capital. So we've been leasing the spectrum, as Kathy mentioned, since about 2006, and that was all an O&M hit. But now that we're planning to purchase it, we're actually going to use capital to do the purchase.
And that's consistent with First Energy as well. It was 100% capital when we purchased it in 2017 and 2018. And we allocated that across our operating companies and between transmission and distribution based on our expected usage.
Anyone else want to chime in on this one? Okay. How are we doing for time here? Oh, we got plenty of time. Next question. What would you do differently if you had to build a fan all over, knowing what you know now?
So for us, I think a couple of the big ones was back to what we talked about for the interference, both self-interference and external ones. Planning that better. Right in the middle of deployments now, and having good procedures and processes about how you get a radio up and running when you're trying to deploy 3 or 4 or 5 a day would have been huge. And I don't know that looking back, I don't know if we could have done all of that in foresight. Hindsight's 2020, but it would have been nice to have more clear procedures, a little bit more of a factory approach to getting radios up and running, and as well as plans for interference.
Kathy, you probably have as much experience with this as anybody. You can't say quit and go to a different company. What would you say?
Yeah, I'm trying to think of what we would have done differently. I know we ran into issues along the way. One of the bigger ones we ran into was with when deploying the cellular backup. The antenna that we chose for the cellular backup ended up not being sealed properly, and water got into it, and then over the winter it froze and then cracked, and so we started seeing some sites just drop. Now, this was the backup path at that point. The site was either dropping or we were monitoring. You could see a big drop in the RSSI. And so we ended up having to go out and replace all 470 of those antennas before we could continue cutting over to the new system, since it was our backup, but when we needed to cut over, we needed to rely on that as our primary. So that was definitely something I would do over, is be careful when choosing antennas, even if it is for your backup network, to make sure that they are going to be able to handle the weather.
All right.
Well, I know it was a pretty easy answer from my perspective. We wouldn't have started implementing right before the FCC license renewals were due, because we spent a couple of years in a mad scramble in every part of our service territory trying to get base stations and remotes up and running. So would have been much more efficient from an engineering and planning perspective. And so folks who are contemplating purchasing 700 megahertz now, they've got a little bit of runway in front of them.
The next question is pretty long, but I think it's relatively straightforward. For the overall panel and for those who perform detailed business case modeling, outside of the benefits of greater reliability and control, if commercial cellular is considered as a competing solution for a private fan, possibly with dual SIM, at what point does the model move from public to private in terms of the quantity of endpoint devices or a given density of base stations serving these devices?
So we didn't necessarily do that level of modeling, but I can tell you that from a strategic standpoint, our rallying cry is to be as free from the telecom carriers as humanly possible. As you saw in my presentation, we have about 3,100 cellular devices out there right now, and that was mainly due to expediency to get them off of the analog lease circuits. And we routinely see entire sections of states when the wireless carriers have issues. We will see hundreds of substations go down. So the faster we can get them off of those solutions, the better.
Yeah, I would say we cellular is fantastic as a backup, but we wouldn't rely on it as our primary. Like Stephen was saying, we had issues early on when we first were installing cellular backup, where I think we had about 100 substations on it at that point, and one day just all of them dropped, and you try calling into the carrier, and it's not just us, it's a whole bunch of people having the same issue. You can't get a hold of anyone. You have no ETA on when they're going to be back online. Unfortunately, this was just a backup at this point, so not such a big deal. But if we had been relying on this as our primary, and then you have system operations going, what's going on? When is it going to be back on? You go, I have no idea. We're just down. So not what we'd want to rely on for primary.
Yeah, I agree. I mean, there's no way for us to get priority, guaranteed service levels, things like that. So it's more than that than density or or availability of towers. It's just not being able to have that priority when and if things do happen. Not being able to guarantee bandwidth when there's congestion. Those are the things that are the big drivers.
Yeah, I would have to agree with all the other panelists. I think the one thing that really kind of drove it home for us is we actually utilize cellular backhaul for a lot of our IoT infrastructure today. And initially, when things were rolled out, it was a sensor data that's nice to have that, kind of will help us. And now it's become critical. And we actually had a loss of service. And the biggest thing for us is there is no priority and, no dedicated SLA for the utility.
All right, it looks like that's all the questions that have come in for us. We have a few minutes left. Should we do a couple just closing comments from each of the panelists here? Hate to put you on the spot, Kathy, but you want to go first?
Sure. I guess closing comments would be I'm looking forward to continuing, and like you mentioned, the next call that we'd like to have discussing interference issues and such that people might be having. Just looking forward to keeping or starting this group and getting users in this band together so that we can talk about different issues that we're having.
Kim, would you like to go next?
Sure. One thing that I can say is since we are kind of at the beginning phases of our field area network discussions and subsequent design, I know who to reach out to now who probably have some really good lessons learned for our team. I think, we've been very successful in the use cases that we've completed so far. And I know that our business folks are actually clamoring for more. So I think especially as these IoT devices become more and more relied upon, that reliability and availability, the flexibility of the design, so you're not having to go back and rework things, are going to be really important moving forward. So I appreciate the group and look forward to talking to you all in the future.
Thanks, Jared. Do you have a couple comments?
Just restating what my other panelists said, I'm really looking forward to this user group. I think it's important for us to get together and speak about our neighbors, and as a collective, so that we're not getting point solutions, and also, communicating how much of a concern it is for many of our organizations. And there's a lot of work that goes into getting these things rolled out and planned and tuned up, and as you're looking to do it, there's going to be lessons learned for you all too. Don't get discouraged. It starts to get easier.
Thanks. Stephen?
Yeah, so a few years ago, it wasn't too long ago when we couldn't have two dimes to rub together for this kind of investment. And now we just, they have an insatiable appetite in both transmission and distribution for more and more SCADA, more and more communications, and we're just scratching the surface on what the end state is going to look like. One of the things that we haven't discussed here is how we're all managing thousands of devices that we're deploying, and we've got some things going on with visualization and operational views of what's up and what's down. And I'd be very interested to hear what other folks are doing. So I look forward to additional collaboration.
All right, thank you. Well, this has been a lively and informative session. We appreciate everyone's participation. There's a couple of final notes here. Any questions that we couldn't get to, or any questions that you think of afterwards, you can direct those to Klaus, and we'll make sure that we get the right utility or vendor to get you an answer. Secondly, through UTC and Klaus, we'll be holding future 700 megahertz A-block users and potential user sessions during the next 12 months to exchange ideas and talk about nuances of deploying within the spectrum band. If you're interested in participating in those feature sessions, please ensure to contact Klaus Bender and provide him with your email information, and we'll make sure that we get you included. And lastly, I want to thank the sponsors for the wireless track at UTC and today's roundtable, Access Spectrum and Select Spectrum. Please visit them at their virtual booths. So thank you everyone for participating today.